Hello, space enthusiasts. Welcome back to the channel where we explore the mysteries of the universe, from the smallest particles to the largest cosmic structures. Today, we're tackling a fascinating and complex question that has puzzled astronomers for decades. Why do galaxies in crowded environments tend to grow larger? This question not only challenges our understanding of galaxy formation, but also opens the door to new theories and models that could reshape our view of the cosmos. The galaxies, cosmic giants of the universe. First, let's take a step back and talk about what galaxies are. A galaxy is a massive, gravitationally bound system consisting of stars, stellar remnants, interstellar gas, dust, and dark matter. Galaxies can range in size from dwarf galaxies with just a few billion stars to giants with 100 trillion stars or more. The Milky Way, our home galaxy, is a barred spiral galaxy with a diameter of about 100,000 light-years and containing around 200 to 400 billion stars. Galaxies are not isolated entities. They exist in a complex web of interactions with other galaxies. Some are found in isolation, while others exist in clusters surrounded by hundreds or thousands of other galaxies. The environments in which these galaxies reside can have a significant impact on their evolution, structure, and size. This brings us to our main topic. How and why does the density of a galaxy's environment influence its size? Conflicting studies and the quest for answers, the idea that a galaxy's size might be influenced by its environment is not new. However, early studies produced mixed results. Some research suggested that galaxies in dense environments, like clusters, were smaller, possibly due to interactions that stripped them of gas and halted star formation. Other studies found that these galaxies were actually larger, potentially due to mergers and accretion of smaller galaxies. One of the main challenges in addressing this question has been the lack of large, comprehensive data sets. Previous studies were often limited to a few hundred or thousand galaxies, which made it difficult to draw definitive conclusions. The results were often contradictory, with different surveys producing different outcomes. This inconsistency left astronomers with more questions than answers. But all of that began to change with the advent of new, more powerful telescopes and advanced data analysis techniques. The Hyper-Suprime-Cam Subaru Strategic Program, HSC-SSP, conducted by the Subaru Telescope in Hawaii, has provided the most extensive data set yet, allowing researchers to examine millions of galaxies in unprecedented detail. The HSC-SSP is designed to capture deep and wide images of the sky, covering a vast area and providing high-resolution data on millions of galaxies. The Breakthrough Study, analyzing millions of galaxies. The breakthrough came from a study led by researchers at the University of Washington, Yale University, and other institutions who utilized data from the Subaru Telescope's Hyper-Suprime-Cam. This study was able to overcome the limitations of previous research by analyzing a dataset of 3 million galaxies. This massive dataset allowed the researchers to perform a much more comprehensive analysis, leading to more robust and statistically significant conclusions. The key finding of the study was that galaxies in denser environments tend to be larger. But how did the researchers determine this? They used a novel machine learning tool known as the Galaxy Morphology Posterior Estimation Network, or GAMPN. This tool, developed as part of Dr. Eritra Ghosh's PhD thesis at Yale, is specifically designed to estimate the sizes of galaxies while accounting for the uncertainties inherent in such measurements. GAMPN works by analyzing the morphology, or shape, of galaxies, and it's particularly adept at handling the vast amounts of data generated by modern astronomical surveys. By applying GAMPN to their dataset of 3 million galaxies, the researchers were able to confirm with high confidence that galaxies in denser environments are, on average, larger than those in less crowded regions. Why are galaxies in crowded environments larger? Now that we know galaxies in denser environments are larger, the next question is, why? Several theories have been proposed to explain this phenomenon, and while none have been definitively proven, they offer intriguing possibilities. Galactic mergers. One of the most straightforward explanations is that galaxies in dense environments are more likely to collide and merge with one another. When two galaxies merge, they typically form a single larger galaxy. In a crowded environment where galaxies are in close proximity to one another, these mergers are more common. Over billions of years, repeated mergers can lead to the formation of massive galaxies. Dark matter's role. Another possible explanation involves dark matter, the mysterious substance that makes up about 85% of the mass of the universe. Dark matter doesn't emit light, so we can't see it directly, but we know it's there because of its gravitational effects. Some scientists speculate that dark matter might be more concentrated in dense environments, providing the gravitational pull needed to draw galaxies together and fuel their growth. This could help explain why galaxies in these regions tend to be larger. Initial conditions. A third theory suggests that galaxies in crowded environments might have started out larger due to differences in the conditions of the early universe. In these regions, the gravitational interactions between galaxies could have been stronger from the very beginning, leading to the formation of larger galactic structures. This idea is still being explored, but it could help explain why some galaxies are bigger than others from the outset. Environmental factors. Another factor to consider is the role of the environment itself. Galaxies in dense environments are often surrounded by hot gas, which can strip them of their own gas and suppress star formation. However, this process, known as ram pressure stripping, might also allow these galaxies to retain a more compact, massive core, leading to an overall larger size. Additionally, the tidal forces in these regions could help to compress the galaxies, further increasing their size. The role of modern technology in astrophysics. The ability to conduct such a comprehensive study is a testament to the power of modern technology in astrophysics. The Subaru telescope's Hyper-Supreme Cam is one of the most advanced instruments of its kind, capable of capturing high-resolution images of vast areas of the sky. But even with this incredible technology, the analysis of such a large dataset would have been impossible without the aid of machine learning. Machine learning is a type of artificial intelligence that allows computers to learn from data and make predictions. In this study, GAMPen was used to analyze the morphology of millions of galaxies, a task that would have been prohibitively time-consuming if done manually. GAMPen not only made the process faster, but also more accurate, allowing the researchers to draw conclusions with a high degree of confidence. The use of machine learning in astronomy is still relatively new, but it's already proving to be a game changer. As more telescopes come online and more data is collected, machine learning will become an increasingly important tool for astronomers. In the near future, we can expect to see even more breakthroughs as researchers use these tools to explore the universe in ways that were previously unimaginable. Implications for our understanding of the universe. The discovery that galaxies in crowded environments are larger has significant implications for our understanding of the universe. It challenges some of the existing models of galaxy formation and evolution, suggesting that our current theories may need to be revised. For example, the traditional view of galaxy formation holds that galaxies grow by accreting gas from their surroundings and converting it into stars. This process is thought to be relatively slow and gradual, taking billions of years. However, the new findings suggest that mergers and interactions with other galaxies may play a much more significant role in galaxy growth than previously thought. This has led some astronomers to propose new models of galaxy formation that place more emphasis on the role of environment. These models suggest that the growth of a galaxy is heavily influenced by its interactions with its neighbors, with galaxies in dense environments, experiencing more frequent mergers and faster growth. The findings also raise questions about the role of dark matter in galaxy formation. If dark matter is indeed more concentrated in dense environments, it could be playing a crucial role in driving galaxy growth. Understanding this relationship could provide new insights into the nature of dark matter and its role in the universe. Looking to the future. What's next in galaxy research? The study of galaxies is one of the most dynamic fields in astronomy, and there's still much we don't know. As new telescopes and instruments come online, we can expect to learn even more about these cosmic giants. One of the most exciting developments on the horizon is the Vera C. Rubin Observatory, currently under construction in Chile. This state-of-the-art facility will conduct the Legacy Survey of Space and Time, LSST, which will produce the largest astronomical dataset ever created. The LSST will capture images of the entire southern sky every few nights, allowing astronomers to study the changes in galaxies over time and detect transient events like supernovae. With the advent of the LSST and other next-generation surveys, we'll be able to study galaxies in even greater detail, potentially uncovering new patterns and relationships that we can't even imagine today. The combination of large datasets, powerful telescopes, and advanced machine learning tools will usher in a new era of discovery in galaxy research. Conclusion: the ever-evolving universe. As we conclude this deep dive into the question of why galaxies in crowded environments tend to grow larger, it's clear that we're only scratching the surface of what we can learn about the universe. Here's the completion of the detailed script, ensuring it's extended to meet the 10,000 character requirement. Ever-evolving universe holds countless mysteries, and the discovery that galaxies in dense environments are larger is just one piece of a much larger puzzle. It challenges our existing theories, inspires new questions, and pushes us to develop better tools and models to understand the cosmos. So what does this mean for the future of astronomy? For one, it shows that we're only beginning to understand the complex dynamics of galaxy formation and evolution. As we gather more data and refine our models, we're likely to uncover even more surprising and enlightening patterns in the universe. This discovery also underscores the importance of collaboration in science. The study we've discussed today is the result of years of work by researchers from multiple institutions, utilizing data from one of the most advanced telescopes on Earth and applying cutting-edge machine learning techniques. It's a testament to what we can achieve when we combine our resources and expertise to tackle the big questions. As we look ahead, there's no doubt that the coming years will bring even more exciting discoveries in the field of astronomy. Whether it's through the study of galaxies, the search for dark matter, or the exploration of exoplanets, the next decade promises to be one of the most productive and transformative periods in the history of space science. Before we wrap up, let's revisit the big question: why do galaxies in crowded environments grow larger? Is it due to frequent mergers, the influence of dark matter, or something else entirely? The truth is, we still don't have all the answers, but that's what makes astronomy so exciting. Every discovery leads to new questions, and every question brings us one step closer to understanding the universe and our place in it. We'd love to hear your thoughts on this topic. What do you think is the most plausible explanation for why galaxies in dense environments are larger? Do you have any other theories or ideas? Let us know in the comments below, and let's get the discussion started. And if you enjoyed today's video, don't forget to give us a thumbs up, subscribe to the channel, and hit the notification bell so you never miss an update. We have a lot more exciting content lined up, from deep dives into the latest astronomical research to explorations of the most mind-blowing concepts in space science. Thanks for joining us on this journey through the cosmos, and we'll see you next time as we continue to explore the infinite wonders of the universe.